Good morning, all. Now I'm telling Unit 2 of Database Management System. And before that, I want to introduce myself. My name is Dr. A.S. Gausia Banu, Associate Professor of Narasimha-Reddy Engineering College, UGC Autonomous Institution. So, Unit 2 is Introduction to Relational Model. The contents of Introduction to Relational Models are integrity constants over relations, enforcing integrity constants, theory, relational data, logical database design, introduction to use, destroying altering tables and use, relational algebra, tuple relational calculus, domain relational calculus. Before starting this integrity constant over relations, we have to learn what is constraints. Constraints means restrictions. So, SQL constants are used to specify rules for the data in a table. That means we are putting some protocols for a table. That means we are inserting some restrictions on the for the data in the table. Constraints or restrictions are used to limit the type of data that can go into the table. This ensures the accuracy and reliability of the table. If there is any violation between the constraints for data action, the action is aborted, that is deleted. So what happening is, for these constraints, for these restrictions, there is some limit. The limit will be on the type of data that can be into the table. That ensures the accuracy and reliability and avoid redundancy in the data in the table. For this, we have to take follow action. If these actions are violated, it is aborted. That is the meaning of this slide. The next slide is, so we are saying SQL create constraints. The syntax for this is create table name, column 1 data type constraint, column 2 data type constraint, like that, column n data type constraint, and close the bracket with a semicolon. The next is the creating statement for database. Show databases. Create database name, use database name, select database name. So creating table, create table name, column 1 data type, column 2 data type, column 3 data type. Example of table creation is create table persons. The attributes can be person ID, which is of integer type, last name varchar 255 characters, special characters, including first name varchar is 256, address varchar is 256, city varchar is 256. Now, so coming to the insert command. Insert into table name values V1, V2, V3, V4, and Vn, and so on. Example is insert to employee, EID, e-name, salary. Values are EID is integer type, so it is 102. There is no apostrophes. That is commas on the head. The next is e-name is varchar, so Alex, and 20,000 is also integer, so it is 20,000. There is no apostrophes. The next is we are creating table person. Now the bracket starts. ID integer type, it's not null. Last name varchar 256 not null. First name varchar not null. Age is integer. Next, create table persons. ID integer not null. It is a unique type. Next, last name varchar 256 not null. First name varchar 256. Age integer. Next, third one is create table persons, ID integer not null, last name varchar 256 not null, first name varchar 256, age limit, primary key is ID. So these are the different types of create where we are using not null. The second accept we are using not null and primary, and third sum we're mentioning primary in the last word. Next is create table orders. Order ID integer not null. Order number into integer not null. Person ID integer. Primary key order ID. Foreign key is personal ID. Differences persons person ID. Next, create table persons. ID integer not null. Last name varchar 256 which is not null. That means there is no null values. So there's no blank spaces. Something has to be filled in this. First name varchar is 256. Age is integer type. We are checking age is greater and equal to 18. Next, create table PP, that is that we are inserting some marks of integer, roll number of integer, foreign key is roll number, difference is mm in the bracket R number. That means we are replacing two tables where one table it can be a primary key, replacing to other key as a foreign key. Next, create table persons, bracket starts, where ID is integer type and it is not null. Last name is varchar 256, not null. First name varchar 256, age is integer. City varchar 256 default tagness, bracket closed and semicolon. The next is we are seeing the index type. Create index IDX last name on person's last name. Next, select star from where condition and select F1, F2, F3 from where condition and update table NM. Delete from TN, drop table TN, truncate table DN. These all are type of constraints. So this type of constraints, what are the different types of constraints we are measuring in this slide? Delete means we are deleting. Drop means that is also a delete command. Next, but drop is permanent deletion, where delete is a temporary deletion. Truncate means we are cutting the values. Suppose we are using 10 characters. In that character, we are using 10 characters, 10 characters. In that characters, suppose we are using some 8, the 2 we are truncating and becoming to 8. Truncation means we are making into a small tables without spaces. Next, string data types. This character type, varchar, binary type. So let's come to character type. A fixed length, Fixed length string can contain letters, numbers, and special characters. The size parameter specifies the column length in characters can be from 0 to 256. Default is 1. Where char, a variable length string, can contain letters, numbers, and special characters. The size parameter specifies the maximum column length in characters can be from 0 to 65535. Binary size equal to character but stores binary byte strings. The size parameter specifies the column length in bytes. Default is 1. Next, where binary size equal to where char but stores binary byte strings. The size parameter specifies the maximum column length in bytes. So the next one is tiny blob. For blobs, binary large objects, maximum length is 256. Next, tiny text. Tiny text holds a string with a maximum length of 256. Tiny size holds a string with a maximum length of 65,535 bytes. So blob sizes, the blob binary larger objects holds up to 65,535 bytes of data. Medium text holds a string with a maximum length of 16777,215 characters. Next, medium blob. For blob, binary large objects holds up to 16,16777,777,215 bytes of data. Long text holds a string with a maximum length of 4,294,967,295 characters. Long blob or blob binary large blobs holds up to 4,294,967,294 bytes of data. That is enumerated, a string object that can have only one value chosen from the list of possible values. Two can list it from 65535 values to an enum list. If the value of inserted there is not in the list, then the blank will be inserted. The values are sorted in the order you enter them. Next, set values val1, val2 to val_n. A string object that can have 0 or more values chosen for the list of possible values. You can list it up to 64 values in the set list. The next, coming to numeric data types, bit size. Next, tiny integer, bool, that is 0 is considered as false. Non-zero values are considered as true. Boolean equal to bool. Next is small integer, medium integer, integer of size, and big integer. So coming to this, bit value byte, the number of bits per value specified in size. The size parameter can hold a value from 1 to 64. The default value for size is 1. Next, tiny integer size, a very small integer. The sign range is from -128 to 127. Unsigned range is from 0 to 256. The size parameter specifies the maximum display width, which is 255. Bool 0 is considered as false. Non-zero values are considered as true. Boolean equals to bool. Next, smallest integer of size. The smallest integer sign ranges from -32768 to 32767. Unsigned range is from 0 to 65535. The size parameter specifies the maximum display width, which is 255. Next, medium integer signed ranges is from -8388608 to positive number. The unsigned range is from 0 to 1677715. The size parameter specifies the maximum display width, which is 255. Next, medium integer of size. The medium integer sign range is from minus to positive of 2147483647. Unsigned range is from 0 to positive number. The size parameter specifies the maximum display, which is 255. Equal to integer. A large integer size range is from negative number to positive number. Unsigned range is 0 to this number. The size parameter specifies the next float size, floating point number. The total number of digits is specified in size. The size digits are of decimal point to specify if the D parameter. The syntax is depicted in MS SQL 801.17 and it will be remotely in future MySQL versions. Float. A float point number uses p-value to determine where it to use float or double for the resulting data type. If p is from 0 to 24, the data type becomes float. If p is from 25 to 53, the data type becomes double size 0. The normal size floating point number. The total number of digits is specified in 0. The number of digits after the decimal point is specified to be the D parameter. Double precision size 0. Decimal size 0. In this, there are two parts. Decimal size 0. Next, decimal size 0. Dec and other is decimal. So in decimal, the exact fixed point number, the total number of digits is specified in size. The number of digits after the decimal point is specified in D parameter. The maximum number of size is 65. The median number for D is 30. The default value of size is 10. The default value for D is 10. Next, dec equal to decimal size of size 0. Data type is again date time, timestamp, time, and year. The date format is YYMMDD. The spotted range is from 100 to 01 to 01 to 9999-12-31. The date and time combination format is YYYY, where Y stands for year, and MM stands for month, and DD stands for year, and HS stands for hours, MM stands for minutes, SS stands for seconds. The supported range is from 1000, 0101, 01 is to 00 is to 002 9999 12 dash 31 23 is to 59 is to 59. We're adding default and on update in the column definition to get automatic initiation and updating to the current date and time. The timestamp values are started as numbers of seconds since the Unix approach 1970-01-01 00 is to 00 is to 00 UTC format YYYY dash MM dash DD HS H and H is to M and M is to yes and yes. The spotted range is from 1970-01-01-00 is to 00 is to 01 UTC to 2038-01-0903 is to 14 is to 07 UTC automatic initialization and updating to the current date and time can be specified using default current timestamp and on update current timestamp in the kernel definition. Time FSP, the time format HS is to MM is to SS. The spotted range is from minus to plus of 838 is to 59 is to 59. Here is 4-digit format. Values allowed in 4-digit format 101901221555 year and 0000. MySQL 8 point does not support year in 2-digit form. So these are some of the rules, set of rules where the DBMS has to follow. Next topic, this is the topic from the syllabus, integrative constant over relations. Till now we have studied what are the basic constants. Now these basic constants are introduced in integrative constant and enforcing integrative constants. And some rules in the relations in the DBMS. Then next coming to integrative constants is nothing but is a set of rules or set of protocols. They used to maintain the quality of information. Why we are giving these protocols? To maintain the quality. Integrative constants ensure the data insertions, updating, and updation. It gives surety for the data insertion and updation. And other processes have to be performed in such a way that data integrity is not affected at all. So while doing this data insertion, updation, and other process, we should not affect the data integrity. So we are applying integrity constants. Thus, integrity constants are used to guard against accidental damages to the database. So any damage which is occurring very suddenly, the integrity constants help to protect the data to the database by using integrity constant. Constraints can be column level or table level. Column level constants apply to a column and table level constants apply to the whole table. So constants can be column level or at table level. Column is nothing but applying to attributes, or the table is nothing but relation. Next, the whole constants is commonly used in SQL. Not null ensures the column should not have null value. Unique means the value it should be different. All the values should be different from one another. Primary key is a combination of not null and uniquely identifies each row in the table or relation. Foreign key prevents action that could destroy links between tables. Check ensures make sure that the values in the column satisfies a specific condition. Default values means set the default value for the column if no value is specified. Create index we use to create and retrieve data from the database very quickly using the index. Types of integrity constants. They are basically four types. The first one is domain constant. The second is entity integrity constant. The third one is differential integrity constant. The last one is key constant. First one is domain constant. Domain constant can be defined as definition of valid set of values for an attribute. That means it defines a valid set of values in an attribute that is called domain. For example, a data type of domain includes string, character, integer, time and date, currency, etc. The valid attributes must be available in the corresponding domain. For example, ID number is 100, name is Tom, first semester and 17th age. As you see in this table, 100, 1001, 1002, 1003, and 1004. Here, 1004 A. It should be of integer. This age should be of integer, but 1004 is mentioned as alphabet A, which is not allowed because age is an integer attribute. Let's see again in detail. So Tom is 100 is called Tom. What semester is first semester? What is his age? 17. What is 1001 is Johnson. What semester is studying? Second. What is his age? 24. Next, 1002. Leonardo. What semester is fifth? What is his age? 21. Next, 1003. Cat or cat. Third semester, 19. 1004 is Morgan. He's studying 8th semester, but the age is not mentioned. We could have either put null, but they mentioned as A. A is the alphabet, but age is a integer type, which is not allowed. So this is one of the domain constant example. Next is integrity constant. Entity integrity constant. The entity integrity constant states that primary key value cannot be null. The primary key, what is the primary key here? Employer ID, which should be underline. This should not be done. Here we have seen the employee's ID is 123, 142, 164. The last row of the employee ID is blank, which is not allowed as primary key cannot contain a null value. This is not allowed. This is because the primary key is used to identify individual rows in a relation, and if in case the primary key has a null value, we cannot identify those rows, so we cannot give a null value. The table can contain a null value other than the primary key field. The third one is the differential integrity constant. A differential integrity constant is specified between two tables. In a differential integrity constant, if a foreign key is in table 1, refers to the primary key of table 2, then every value of the foreign table in table 1 must be null and be available in table 2. For example, there is table 1 and table 2. Table 2 is nothing but like department number and department location. Your table D number is the primary key. So it is getting referencing to the other table 1, which is acts like a foreign key. So, so here what happening is, yeah, you see in table 2, 11, D number 11, 24, 13 is there. When coming to table 2, 11 is there, 24 is there, 13 is the last, in between 18 is there, which is not allowed because it doesn't exist in the primary table. So this is called differential integrity constraint. So we're checking for this, which is not allowed, and it is a big error. The last one is the key constraint. The key is entity set for use to identify the entity, even if entity set uniquely. What is a key? Key is nothing but an entity set unique. So that is can be used and identified in the entity. The entity set can have multiple keys. Entity set can have multiple keys, but out of which only one key is selected, that is called primary key. The primary key can contain a unique value in the relational table. For example, a year, ID, name, semester, and age is there. ID, some of the few IDs, let's read from starting. 100, 101, 1002, 103, 102 in the last line. 102 is also in the third line. The names are Leo and the 102 in the last is Morgan, which is not matching, and this is not allowed. It's like a duplicacy because all rows must be unique. So this is the fourth constraint.